Hi and welcome. So another lecture here today from me to you about password cracking. So we're going to talk about basically how you can crack passwords and a little more than that. So let me show you the agenda today. So we have the overall agenda here. We're going to talk about what a password is, what a hash is, what an encryption is, early encryption, different kind of encryptions, what is salt, pepper, how to store password, how to crack it with different tools, and then I'm going to do a demo of the overall issue with weak passwords. So this is of course just passwords, so how we're going to crack a password. Let's get started with this. So basically let's just talk about what is this password, because we all have it, we all use it. It's something that in general is going to grant you access to whatever resource you need access to. Now that could be your Facebook account, it could be your Google account, it could be some cloud drive, it could be your phone. And I wanna stress the fact that a password can be more than just actual, digits and numbers. It can also be biometric, but in this particular case here, we're trying to crack a password. So I only mention, letters and numbers and signs for this particular tutorial. But of course, biometric, passwords, as you look at your smartphone, then it opens because you can read your face or your fingerprint, stuff like that, which is also a password, just not the same as a text representation of a password, which this tutorial is all about. Now, I want to say that the most important part, I'm going to break it right now, is that you hash your password. Now, we haven't really talked about what that means, but let's just stick to the fact right now. You need to remember you need to hash your password before you store it in some database. So first of all, passwords itself, when you just type them directly to the screen or you write them on a piece of paper like the image show, that is what we consider as plain text. So when you go ahead and do some hacking challenge or something like that, and you ever hear the word called plain text, well, we basically refers to a password that has not been encrypted or altered in some way to save its secret. Imagine that anyone could read your thoughts in a certain way, then everyone would know what your password was. But if you could some way encrypt your own mind so only you could read it, well, that would be a great idea, and this is what you do with passwords. So before you hash it, and hashing is a certain way of working with a password. Now we're getting to the point of understanding that hashing has something to do with the password that needs to be changed, so we cannot just read it directly. Imagine having plain text passwords saved in a database. That is of course a big no. So plain text passwords should never be stored, and they're really easy to misuse because they are plain text. I hope that kind of settles the idea behind why that is a bad idea. So now we're going to talk about what is actual encryption, because we often hear someone talk about, so did you encrypt it? Are you using encrypted traffic? Do you have your certificate on your web page? We're like, yeah, but so what is all this? Now, the image below shows that when you take some letters, let's say A, B, C, we can change them to other letters. Of course, this is a really simple type of encryption, so it should never be used, but it's just to demonstrate the general idea behind what an encryption algorithm actually does to your plain text. And that creates what you call a cipher. So if the text DEF became ABC, then ABC, that part would be the cipher text. So that is the encrypted part of what we consider as the plain text part, which is the top part here. So in very simple terms, you can say that a cipher text is basically what you call the encrypted text. Or you can also say more commonly that the encrypted text or the cipher is the way the text becomes unreadable. It's a very non-technical way of saying it, but it kind of explains the general idea. So we're also going to talk about what is a hash now. And a hash, if you point your eyes towards the image here, it takes some arbitrary data, some sort of data you put in, doesn't really matter how long it is. It's gonna go inside this, funnel here, and then, there is some sort of function running, and it will output a fixed length string. That is usually called also the digest, which is going to output to you some weird, collection of letters and numbers. And that is usually hexadecimal notation, which is also the table you can see here on the top, which is, if you know the binary, you can say like the number 1 in hex is that in binary, and the number A in hex is this in binary. In reality, in hexadecimal, every number from 0 to 9 is the correct numbers in certain ways, but number A is 10, B is 11, 12, 13, 14, 15, so F is 15. Just have a single letter like F, it's 15. Doesn't really explain why the hashing algorithm uses these kind of notations. However, what is important to know, if you identify some sort of, string that is composed of, letters from A to F and numbers, then it is most likely some sort of hash, and for you to figure out which kind of hashing algorithm that is used to hash the plaintext to its cipher, to use the correct words. I want to say straight up that many people use MD5 hashing algorithms still, which is of course not a good idea. I have seen some implementations of MD5 that's been, I guess usable, but the general idea is that MD5 is somewhat broken and you should not use it. You should use the bcrypt or scrypt algorithm instead. That would be my pure recommendations. Now that we talked about, casually what, passwords and plain text is a bad idea, we need to do some sort of encryption to it. So the general idea behind encryption is that you take some sort of text, as the image shows here. You encrypt it with some key. As you can see, there's a small lock that locks it. That is the analogy to use. And then it becomes like unreadable, and it's like just a big bunch of mishmash. And then you decrypt it by using the same key. As you can see, it's the same key. It's just the decrypt key. So basically, encryption is a part of the hide your secrets. It's also a part of the confidentiality thing when you talk about this CIA triad and all that. That's a different topic, but I'm just gonna drop it so you can take a note right now and say CIA triad, CIA, confidentiality, integrity, and availability, the 3 buzzwords in security. So basically, when you work with encryption, you work with confidentiality because you are hiding, you're trying to avoid, someone get access to in some way to your secrets. So there are different kind of encryptions you probably heard of, like hard disk encryption, or your internet traffic needs to have a TLS certificate. Now, in old days, not that many years ago, commonly referred to as SSL certificate, or you still say HTTPS. That is the small lock you look for in the browser. So that is still something that is going on and should never be neglected to be implemented. Encryption also implies decryption. So when you encrypt something, you can decrypt it. That is really what encryption is. Early encryption was like stuff like this. You had like the Caesar cipher, something like that. That's many years ago, many moons. And you could notice that, you had some sort of wheel, and then you could, take some message and say like, so the A is replaced by the B, and the B is replaced by the K, and so on. And that was something they used in the Roman era, which also refers to the name of Caesar cipher. But of course, these days with computer power, that is not useful at all. Even so, if you talk about the Enigma, for example, from World War II, it is of course also not safe anymore. Just for the common people without a computer, stuff like, Caesar cipher will still be difficult to cipher in a way, because you need to know exactly what is the table you look up against. So the Enigma, of course, will be even more hard to break without a computer, but with computers these days, it's a thing that, we have the algorithm, it is broken, we know everything about it, so it's really easy to decrypt the text. There's a certain type of encryption called ECB, or electronic codebook, which is the type of way that algorithms can work. Now, the thing about this electronic codebook, if you look at the image here, is that we have a key, and that could be the key we use to encrypt with, and that is the same key we need to have to decrypt the text we encrypted, right? So you give it some sort of text. Now, the image here kind of implies that we have a block of text, which in this case is 8 blocks. It could be 4. You know, my example here is 4 blocks, but the image is 8 blocks. So the same 8 blocks would be taken from whatever long string you need to encrypt, and the same key would be used to generate the ciphertext or the cipher from that plain text. Now that kind of implies that if you had the same key, and let's say you had like 16 A's, the letter A, right? And you encrypted that with the same key. So the first 8 letters of A, you encrypt with the key. Then you get some mishmash. The next block is the next half of 8 letters of A, which is going to generate the exact same cipher. So you can actually begin to guess a pattern, because you can see, oh, so if you see occurrences of the same block, you can start guessing what that could be. And if you can start guessing what that could be, you can start breaking and guessing what the key was. So the use case for electronic codebook is something that should be, you know, maybe you want an extra layer on your application and you want to encrypt with a very weak encryption, but just something extra to put on, you know, some extra spice, right? Then you can do that on chats, or, you know, stuff on your mobile phone that just need basic sort of encryption. You should never use this for, you know, really heavy duty stuff like passwords and stuff. This is not the idea. You can also use another type called Cipher blockchaining, and it is lower than electronic codebook, but it's more safe. It's a little more complicated in the image, but the general idea is that you start with an initialization vector, which is kind of well, where you start in the encryption, and to make it simple, then you have a key. And that key is used as the next block's initialization vector. Sorry, that cipher, is used for the next initialization vector. So the cipher is used along with the plaintext and along with the same key still, but because you used the already encrypted block of text, the thing is going to be impossible to break unless you do a backwards, you know, decryption. So if you have the middle package and you didn't decrypt the last package, it should not be possible to decrypt this, because you need the key from the other one. Of course you can brute force and all that, but it's getting less and less practical. And that is a general idea behind encryption. You know, it should be practical to encrypt and decrypt. It should be impractical for hackers to try and brute force the way, you know, guess the key. So if you look at them like versus each other, as we talked about, if you use electronic codebook, you can see occurrences of the same. If you encrypt an image, for example, then that could be, you can still see it's like, you know, this penguin, because the same color, you know, the same amount of, you know, the block you take to encrypt will be the same, so it will look the same. If you use Cipher blockchaining, it will be a total mishmash, because everything will use each other. So the prior encrypted part of the cipher will be used to encrypt the next block, so everything will be more difficult to break. Now, I want to say that in some situations these two types of algorithms can be safe to use. You know, I would probably look at, you know, electronic codebook for less easy, fast encryptions that shouldn't be that safe, but just a small layer. And for Cipher blockchaining, I would definitely look at that for if you're having some, you know, a little more that doesn't require speed, then you can use it. But in reality, this is more used in school situations to explain how different kind of encryptions are used. Of course, you can also increase the block. If you go back to this image here of electronic codebook, so if the block is, let's say it's 64 bytes long, so 64 characters, and that is the only amount of length you can put in, and you can maximum give it 64. well then this type of encryption is of course okay in a certain way, because then you just need a really long encryption key, and then it will be difficult to break it. But that is of course a very specific, narrow scenario I'm going to give you right now, but just to mention a few things you can use. So we're going to talk about what is salt now, right? So salt is something extra you can add. So when you encrypt your password, and this is something you probably do with the hashing algorithm, as the image implies, that you have the hashing algorithm and you then salt your password. Now, many people they find salting a bit weird to understand, but it's basically just an extra secret you put on. So let's assume now that you have the text, you have the password you wanna encrypt, or you wanna hash it, sorry, and that password is just for the simplicity's sake, it's called password 123. Then if you hash that, it's pretty easy just to look it up and find it somewhere, that hashed string, because it's very basic. It's a weak password. I'm going to show that later in the tutorial. It's like a small demo of why weak passwords are bad. But if you add the salt, that is an extra small amount of text that you put either in front or back of the password, and then you hash both things. Now all of a sudden you need to have that piece of salt too, which is commonly stored along in the database beside the original hashed string that is your password. And the important part to understand is salts are unique per password. You can also add something called pepper, and that is even more. As you can see, you have your password, your salt, and your pepper. Those positions can change. It can also be salt, password, pepper, or pepper, salt, password, whatever you need to do. Just important to know that you need to basically do it in the right order every time, else you will never get the same result. Because to just recap the hashing functionalities is that you're gonna get a fixed length string out every time. That is a direct checksum, which is another word for hashing, of the string you're hashing. So the whole string, which would be password, which is the word, the salt and the pepper, everything. So where's the pepper stored? Now commonly it should be stored in a hardware. It's a bit expensive. You can also have it in a secure API, and I even seen some have it in files in the hard disk. But that kinda is not really the purpose. I understand why you're doing it. It is better than nothing. It should not be saved in the database, but if the database is hacked or leaked in some way, your password should still be somewhat safe, because the hackers do not have the pepper, which is why you call it pepper. But there's no more than that. It's salt and pepper. You don't go curry and paprika and all these kind of things. That is a step too far, if I say right now. Alright, so how to store a password. Now that is another thing, another talk, a very long talk. Should that be saved in a file or database and stuff? Well, it really comes up to the fact what kind of operating system you're using. When you're creating a web page, web application, you use a database to store your passwords in, which is commonly known as the way you do it. If you're using Linux operating systems, you should probably know about the etc shadow file, which is the file where all the passwords are stored. Of course, they are hashed. But if you can access that file, you can dump that and you can start and crack it in some way. There are also some passwords that can be stored in the memory, but that is probably more like some memory-based databases, which is commonly used in test environments and stuff, because you don't need to write stuff in the hard disk. So it saves space during tests and just test, I guess. So the general idea how you can crack a password, how to hack a password, how to brute force a password, the different ways people are saying it. So just want to say that, whenever you're going to crack a password, in reality it refers to you're guessing it. So passwords cannot be cracked in a way. It's not like you have a layer of concrete around it and then you can just crack it open. That's not how it works. You basically need to guess the key in some way. The problem with a hashed password is that there's no key. It's a one-way function. So hashing refers to one-way encryption, and it implies no decryption. So you cannot decrypt a hashed thing, a hashed password, a hashed text. So you need to guess. So in order to guess that, you commonly do that through a word list, which is the first one on the list. Now, through a word list, you guess and say, is that the password? Then you hash it and say, compare the hash with your hash. It's not. Then you continue until they are equal, and then it says, oh, so they're equal, so that is the password. You can see that is a long process. Brute forcing is a bit more, it's kind of the same as a word list, but just more dynamic. You just say start brute forcing, you have an idea that the password is within the length of 8 to 16 characters, and then you give the brute forcing tool a amount of letters and range you should use, and then just tries, and that takes a long time. You can also do direct guessing, just typing with your fingers, or you can use something called a rainbow table. Now, a rainbow table is basically just a big file you download with all passwords that is hashed to a certain algorithm within the length of, let's say, 8 to 12 characters, and then you have it. You know that you have the password because rainbow table have all occurrences of passwords that are within the length of 8 to 12 or 12 to 16 or 1 to 6 or 1 to 8, whatever rainbow table you want to download. That is of course a kind of the same as a word list. It is just hashed already, so it's faster to try and go through and find the actual clear text password using a rainbow table. However, it also really big, so it can be many gigabytes, like 200, 300, 400 gigabytes, 500 gigabytes of file, depending on how long you think the password is. Now, all this guessing and stuff is really not that practical if you have a good use case of salt in your password, because then you also need to salt. If you're ever gonna do some hacking exercise, a hacking room, or capture the flag, or whatever you're gonna do, like ethical, if you don't have the actual salt of the password, it's going to be real difficult to brute force it, because you need to brute force the salt as well, which is just going to increase the whole, timetable to like insanely long, and maybe you don't want to use like 5 months or 7 months just waiting for something to happen. As you can see in the table below, if you have like, lowercase letters up to the length of 8, and this is the case that many passwords these days are actually within the first block here. You say lowercase letters only, and people choose letters, and it is within the length of 8. That is the case for many web pages. Say, oh, so 8 is enough, because we have to like feel the users need not to remember their own password, which is extremely bad idea, but they do it. So most of the password we find is actually within the length of 8, and that is kind of instantly. We can guess it instantly. Almost like instantly, like a few seconds or something like that. That is instantly. I would say even a few minutes is instantly into my eyes, but it's really fast. So really consider about the passwords and use salt, and maybe even, if you can do pepper, that is good, but most people don't have that resource, so use salt. And just using a salt kind of nullifies this table totally, because then we also need the salt, and it kind of gonna take impractical long time to break the password or guess it. So there are different ways you can crack passwords. Now, we've got something called CrackStation. It's basically just a web page in an open database full of hashes and the plaintext equivalents, and then you just look up whatever hash you have, and it's gonna tell you what is the plaintext. So it's just basically just a one-to-one lookup. That's it. And it stores hundreds of millions of passwords. I think it's billions, that you can find. So I'm gonna show that in a few moments. You can also use a tool called John the Ripper, which is a tool that's made to crack passwords. Now, I'm gonna suggest you go ahead and just look it up. Go to Google and do like how to use John the Ripper, or John the Ripper cheat sheet, John the Ripper examples, and it's really fast. It can crack a lot of stuff. Usually it ships with like Linux Kali distribution or other popular distributions. I think it's more or less, I think it's also created for Windows, but hacking in Windows is like, you don't do that. There's also another tool here called HashCat, which is somewhat the same as John the Ripper. It's more commonly used to crack other type of passwords like SSH or zip files and stuff like that, because, well, it's just the way it is. People use that. But you can also use it for stuff like John can also be used for SSH and zip files. It doesn't, you know, it's usually called like SSH to John or zip to John or something like that. That is the command. When I have to think about it, I usually use John the Ripper for cracking, you know, SSH and zip files, to be honest. But it is kind of up to you. HashCat can do many things, so yeah, it's also a tool you can use. Now, for the sake of this, I'm gonna demo 4 different kind of hashed passwords, and I did use the algorithm called MD5, and that is just to make it a bit easier and fast for you to see and watch. So what we're gonna do now is basically take these passwords here, go to CrackStation, just paste them in. Now we don't know these hashes, we don't know what it is, and you can see that it looks like, you know, what I said, like letters from A to F and some numbers. So we're gonna crack it, and it's basically just lookup. It found 3 out of 4, basically meaning that this password here that is creating this hash, it doesn't have that in the database. So the first one is hello 123, password 44456, and someone 123. Now, funny enough, these kind of passwords are used in the industry a lot. So I'm not saying that you should never do that, of course. But that doesn't mean that this is safe. So let's have a look at it. When I created this, I did it with, this is the password we couldn't crack. It's called yo what up. And it is not a safe password. It is just not something that CrackStation thought of saving. And CrackStation is not the the way to go when testing a password. It's just one database you can use to find really bad and easy to look up passwords. The conclusion to all this is that you need to think about creating a good password, and even though that, you know, CrackStation or website cannot show that the password of a hash, it doesn't imply that the password the hash is behind is a safe password. So I really hope you use this video for something, explaining a bit more about, you know, how to crack passwords, what to do, some tools, some overviews, some ideas and theory, algorithm talk and stuff like that. If you have any questions, leave a comment below and I'm gonna get back to you. So until next time, I'm gonna say have a really nice day cracking hashes, and love to see you again.